Hello, welcome to Dimensional Analysis Movie 1. This is the first movie of three, or possibly four or even five, movies that explain dimensional analysis and using unitary rates, factor label, to make changes. The concept of dimensional analysis is simply this: that if I multiply a number by 1, I don't change its value, the multiplicative property of 1. In other words, the numerator will equal the denominator. It's a factor of 1. So if I multiply a number, let's say the value is 5 centimeters, by 100 over 100, it's not going to change the number. However, if the numerator is 100 centimeters and the denominator is 1 meter, we say that that's an equivalent expression, and it's still a factor of 1. When we use dimensional analysis, we use scientific notation, and we use exponential rules as well. And there are going to be 7 exponential rules given here. The first is a to the m times a to the n equals a to the m plus n, where if you have like bases multiplying, you add the exponents. The next one is a to the m over a to the n equals a to the m minus n, where if you have like bases and you're dividing, you're going to subtract the exponents. So when you multiply like bases, you add the exponents, and when you divide like bases, you subtract the exponents. If I raise a ratio to q, it would be a to the mq over a to the nq. So you're distributing the q to both the numerator and the denominator, just like as if I have just a to the m raised to the n, it would be a to the m times n. Here is simply some very simple rules that should be self-explanatory, except that a to the 0, anything to the 0 equals 1, and a to the 1 equals a, etc. Now, if I take the reciprocal of a base, I take the additive inverse of the exponent. So 1 over a to the n is a to the negative n, and 1 over a to the negative n is a to the positive n. Reciprocal, additive inverse. Here are the conversion factors. These are prefixes that have a specific meaning relative to the size of the dimension involved. So, for instance, we know gigabytes. That's G. That's billion. 1 billion is giga. 1 trillion is tera. You'll be seeing tera much more often. You have terabyte storage devices for computers. Milli is very familiar. Now let's make some conversions. And I want to show you a trick to shorten your method. So if I change this value from kilometers to centimeters, I first will change kilometers to meters and then meters to centimeters. So 3 times 10 to the 4th kilometers will become 3 times 10 to the 9th centimeters. And the kilometers cancel and the meters cancel. However, what I want you to look at is that middle portion, 10 to the 3rd meters over 1 kilometer and 10 squared centimeters over 1 meter. Look at that value and you'll see that that is going to be 10 to the 5th centimeters. And so you look at kilometers and you look at centimeters and you say to yourself, all right, well, what is the absolute difference between 10 to the 3rd and 10 to the negative 2? It says, normally I prefer to use a coefficient of 1 in front of the larger dimension. Then ask, how many smaller units are in the larger one? And in order to answer that question, it says, check out the absolute order of magnitude difference between the two units. It is 5. So you say to yourself, okay, so there would be 10 to the 5th smaller units in the larger unit. Now, let's practice. We know that we know that tera is 10 to the 12th. We know that milli is 10 to the negative 3. So you say to yourself, well, what's the absolute difference between 12, a positive 12, and a negative 3? Think of a number line. Put a dot at negative 3 and put a dot at positive 12. The absolute difference is going to be 15. What's the absolute difference between giga and tera? Giga is 10 to the 9th and tera is 10 to the 12th. It would be 3. So there would be 10 to the 3rd giga in 1 tera, etc. So let's continue to look at this. Consult the table. What is the absolute difference between negative 2 and positive 3? It's 5, just like we said above. 10 to the 3rd meters and over 1 kilometer, and 10 squared centimeters over 1 meter, and you're going to get 5. So that's how we do it. Now what we'll do is we'll do some practice. First of all, we're going to look at the conversion chart, the chart for prefixes, not really conversions. It's prefixes that lets you know the size of the base 10 in terms of a prefix. Some of these are going to be very familiar to you. For instance, tera. We have external hard drives now with 1, 2, 3, 4 terabyte capacities. We have gigabytes now. We have megabytes, obviously. Not too many years ago, our biggest storage device, or most common storage device, was a 1 megabyte, 3.5-inch square floppy disk. And then years and years ago, you had very large ones. You had 6 inches, you had 18 inches. You had very, very large floppy disks. Then you had DVDs, you had CDs, which further increased the size of the storage capacity. In chemistry, we use milli a lot. We use kilo a lot. The standard mass is a kilogram. So some of these are going to be very, very familiar to you. So keep this table in front of you. They're very common in many textbooks. We have one in our chemistry textbook, and we have them online, etc. So keep this value, keep this table in front of you, and we'll do some practice problems. So I'll uncover the first couple of columns, and then we will proceed from there. For instance, femto to exa would be negative 15 to positive 18. So the absolute difference would be 33. A to H, A is negative 18, and H is positive 2, so that would be 20, the absolute difference. Mega to milli would be 6 and 3, would be 9. Micro to giga, micro would be negative 6 and giga would be positive 9. The absolute difference would be 15, etc. So, and also many of these prefixes are familiar to you. Tera, nano, nanobytes in the bloodstream. Many science fiction movies and books are written about that. You have milli, which is very common in chemistry. Mega, hecto, which is a little bit more unusual, but it's still not that rare. Femto, centi, kilo. So now let's look and see what we have for the first one. So yeah, that would be 33, because it would be negative 15 and a positive 18 would be 33. The next one would be negative 18 and a positive 2, which would be 20. The next one would be 6 and negative 3 would be 9. The next one would be micro, would be negative 6, and 9 would be 15, etc. So I'll let these run. The first the first column there, 33 to the end, that's 9 problems. They're running at about 10 seconds each. And then it goes down to 4 seconds. And I will see you at the end of this particular worksheet to see how you've done. So that's it for this worksheet. I hope that you find it easy now. And there are bound to be mistakes. I'm sure I will make a mistake in one of these dimensional analysis worksheets. Just make sure you tell me. And if you're one of the first to tell me that I made a mistake, I will give you some extra credit. Well, if you're my student anyway. So write a comment. Tell me what you think. If I make a mistake, let me know, please. And this worksheet is a little bit different. I want you to cube the difference now. For instance, femto is negative 15 and exa is positive 18. That's 33. And 33 cubed would be 99. And then A to K, A would be what? A would be negative 18 and K would be positive 3. That's 21. So that would be 63. And then negative 12 and positive 15, that'd be 27, so that would be 81. So 63 is the second one. You have 99, 63, and then 81. And then the femto would be negative 15, and atto would be negative 19. That would be 3. 3 cubed would be 9. And I will let this run again till the end and see how you did. So now we have 27 would be 3 and 6 would be 9, 9 cubed. The last one would be -2 and -1 would be 1, so 1 cubed is 3. So now let's do some example problems, for instance. Make the following conversions. So you have 5 times 10 to the -7th kilometers to nanometers. The absolute difference between the order of magnitude is 10 to the 12th, 10 to the 3rd, and 10 to the -9th. And then let's see what B is. Set up a ratio that will cancel the kilometers and add the nanometers. So sometimes you divide to cancel, and sometimes you multiply to cancel. The key is you're multiplying by the reciprocal. Put a coefficient of 1 in front of the larger dimension. That's kilometers. Okay, so you have nanometers over 1 kilometer. And then you're going to say, well, how many smaller units, how many nanometers are there in kilometers? Well, if the absolute difference is 9 plus 3 is 12, it would be 10 to the 12th. So let's see if that's correct. Yeah, so it'd be 10 to the 12th nanometers over 1 kilometer. So that's going to be your ratio in order to make the conversion. That's going to be, that ratio is called a conversion factor. That's your conversion factor. It's a factor of 1. The numerator is equal to the denominator. So when that happens, it's a factor of 1. And if I multiply that times 5 times 10 to the -7th kilometers, I don't change the value. But I do get a different looking answer, and that is -7 and a +12 would be, let's see if that's correct. So yes, that's correct. You have 5 times 10 to the -7th times 10 to the 12th. You're adding the exponents. -7 plus a +12 is going to be a +5. So the answer is 5 times 10 to the 5th nanometers. So what I'm going to do is I'll let this run, and there are going to be several examples like this, and see how you do on them. I'll just let this run without narration. Good luck. So the last one of this type, you're going to change 2 times 10 to the third EG to PG. So that will be exa, that's going to be a positive 18, and pico is going to be a negative 12, so that'll be 30. So that's my conversion factor. 10 to the 30 little guys into the one big guy. So because the absolute difference between E and P, capital E and small p, is 30, 10 to the 30th. So it'll be 10 to the 30 picograms in 1 exagram. So I'll use that to make my conversion, and there it is. So the EG cancels, I'm left with P, and I multiply 2 times 10 to the third times 10 to the 30th, and I get 2 times 10 to the 33rd. Now I'm going to do one that's a little bit different. I'm going to say, well, what is 4 times 10 to the negative 6 millimeters cubed in picometers cubed? So I need to know the difference between millimeters and picometers. So it's going to be negative 12 and negative 3. So that'll be negative 9. So that'll be a 9. So 9 cubed is 27. So I'll let that run a little bit and see how you do. So I'll speed up the frames. So we have the difference of 9. So we want to cube. If you cube that ratio, 10 to the 9th picometers over 1 millimeter, even though millimeter is small, it's larger than the picometer. So I'm going to put it in parentheses, then I'm going to cube it, and you're going to cube the numerator and the denominator. Remember that rule, that exponential rule. You cube both, the numerator and the denominator. So I get 10 to the 27th picometers cubed over 1 millimeter cubed. Remember, 1 cubed is 1. So then I'm going to take that value, and I'm going to put that into my equation. I'm going to make an equation. So 4 times 10 to the negative 6 millimeters cubed times that conversion factor, that's what it is. And then I'm going to bring over my 4 times 10 to the negative 6th, and I'm going to bring over my 10 to the 27th, and I'm going to get 4 times 10 to the 21st picometers cubed as my answer. All right, so now let's do another one and see how you do. I'll let this run till the end. And what you'll do is you'll utilize these rules and practice exercises to do some conversions, to do some practice problems. I have 3 movies right now that I'm making. I'm making a 4th, and take them individually. Take them 1, 2, and 3, and see how you do. All right, have a great day. All the best. And don't forget to ask me questions. If I make a mistake, please write a comment. And if you're my student, I'll give you some extra credit. And have a good day. Bye-bye.